It's been a while, I know, but life sort of happens. Today, we're going to be talking about pull requests. Pull requests is a very popular way to introduce changes to a code base. Some people are not even familiar that there are other ways to do code change reviews besides pull requests, which is fine. Pull requests were popularized by GitHub, and I'm going to make another video later on to talk about the history of pull requests and when they came about and how they got so popular and what came before. But that's not the purpose of the video today. Today, we're going to talk about what makes a good pull request, what makes a bad pull request, and at the same time, we're going to talk about how you can leverage GitHub Copilot and GitHub Copilot chat to make the process of writing code changes better and to make the process of reviewing pull requests much smoother and much better for you and your team. Stay tuned. We're going to get started right now. I delivered this talk with my colleague Calvin Chang at GitHub Universe earlier in November. GitHub Universe is GitHub's biggest conference. We were on the demo stage when we delivered this talk, and unfortunately it was not really recorded, and that's why I'm making this video today. So we've all seen pull requests like this one. I'm gonna give you a second to tell me or to figure out on your own what's going on with this pull request. Cool. So the first thing that's not really great is the fact that there is no description of what is being changed. And this is very important, and I'm going to detail why in a second. But the second problem with this pull request is the fact the commit messages aren't very descriptive. They're telling us that there are some changes happening around this particular file, and maybe the author is iterating a few times and, trying to figure things out and make things work, but it's not really telling what are some of these changes. So for the reviewer, they cannot really, from looking at these commit messages, understand what's really going on. Other pull requests are sometimes also looking like this. And also, I'm going to give you a second here to figure out what could be wrong here. 655 file changes. Sometimes these things are inevitable, especially if you're introducing changes across an entire code base. For example, you're changing an entire library. However, it's very difficult to review a large change like this one, and these changes are very, very risky, right? So we would want to definitely avoid making pull requests like this one. It's not always that breaking changes are introduced out of ignorance or malice. Sometimes they are introduced by just mistake. And sometimes maybe our linters can introduce formatting changes that are not necessarily wanted. And it can be argued that these things can be captured in the CI workflows. But again, let's try to avoid those from the get-go instead of, dealing with these problems later on. Good pull requests are hard to create. They sometimes are boring and mundane. We've already done the work, we've written the code. Why do we need to sit down and rewrite everything that we've done, but in a different language? Nobody wants to do that. It's double the work, and sometimes it's quite time consuming. And for many of us, English might not necessarily be our first language, or whichever other language you're trying to use. And sometimes our writing skills aren't really allowing us to express ourselves as easily as we could do with the code changes that we've introduced. So why do we really need to sit down and provide all of this context? People can just go and read the code, right? That's a very common argument that I hear all the time. And I'm going to respond to these in a second once you really start talking about what constitutes a good pull request, and I'm going to explain the why. So what does really a good pull request look like? A good pull request documents what was changed and why. It also documents the caveats and trade-offs of the code changes we've introduced. It documents the risks and security assessments that we've done and we've completed and that we want the reviewer of the pull request to be aware of. It also documents our rollout and rollback plans, okay? Now, there could be a lot of arguments as to why do we need to do all of this work. And in my opinion, this is very, very essential for the following reasons. One, if you work in the same office, it might be beneficial for you to do more in-sync types of code reviews. Why? Because you could just bring everybody together and then you can go through the code together and you can discuss all of these things. However, the problem with that is sometimes people will forget to raise some of these things. And unless we have sort of a templated way of filling in the details, right, some of these details might be omitted or might be forgotten. And this is where problems start to arise. Now you would say, why do people need to ask about these things? We can already write workflows that can check against all of these problems. And that is definitely true. However, whatever you're gonna be writing in terms of workflows are not gonna be able to understand the code from a semantic standpoint, and they're not gonna be able to reason about the design decisions that were made. So these design decisions, they have to be communicated and written down and documented in a way or another. You could argue that you could document these elsewhere. That's totally fine. I am here discussing and describing the process of utilizing pull requests for both reviewing code changes, but at the same time documenting why these changes were made, what was going on in the minds of the engineers who proposed this change, what are the things that were thought about at that point in time, and what were the things that were intentionally dismissed when the pull request was actually made. I often look at certain commits in my repository, and then I would go to the pull request that introduced these changes to really understand what was going on at that point in time. I often hear a lot of developers complain, oh, this code is garbage, this code is bad, this code is this code is that. However, we all have to deal with constraints whenever we're trying to introduce changes, and it's not always possible for us to come up with the perfect solution to everything. Oftentimes, we have to introduce trade-offs, and oftentimes our solutions have caveats to them, right? And it's important for us to document these. In terms of risk and security assessments, the same problem applies. We need to tell everybody what are the risks that were considered so that nobody can come in and question them. And even if they do question them, we already have answers for them. And finally, rollout and rollback plans. As much as we think our process for rolling out and deploying changes is reliable, which is great if you have that perfect, but oftentimes things don't go according to plan, and sometimes the engineers who wrote certain changes are forced to write the change in a way that sometimes doesn't fully conform to the deployment process. So there might be some manual interventions that need to happen whenever we test this change in production, for example, and we see that it's failing, and or maybe we need to roll back from staging, or whichever way you design your workflows or your environments. I am personally in favor of trying to test as much as possible in production and have a very clear methodology to roll back changes that are introduced very quickly if we have problems that arise. I've been working like this, or we work like this at GitHub for the longest time, and I honestly cannot think of a better way to introduce changes beyond this one. Obviously, this cannot apply to all of the different industries, and it is a way of working for a lot of SaaS companies who build SaaS products. GitHub is one of them. And if you are lucky to be working in this bracket, then this is a good way that I would recommend that you adopt. Now, to make things a little bit more concrete, I have made a series of videos where I have created this small GitHub CLI extension. You can go and check them out. We're not going to go through this code base. What we're going to do here is we're going to take this as an example. We're going to introduce a small change. We're going to create a pull request out of this change. And I'm going to show you how you can utilize GitHub Copilot to make sure that the pull request you create is as good as it can be. So I'm going to jump to my code editor now, and we're going to get started. Before we dive into the code, I want to respond preemptively to some of the criticism around pull requests, specifically from the folks who promote practices like, XP or pair programming and anything of that sort. Pull requests and pair programming are not mutually exclusive, meaning if you choose to adopt them in your workplace, pull requests will not prevent you from pairing with anybody on anything. As a matter of fact, using pull requests as a gating mechanism to merging changes to your main branch doesn't necessarily mean that all reviews need to happen asynchronously via comments on the pull requests and whatnot. You can just as easily grab someone and pair with them on reviewing your pull request. That's something I often do with my colleagues as well. I think it's just a better dynamic to chat around things as opposed to bouncing comments on and off. Now, the second criticism is about trust, that organizations should trust their individuals, or they should trust their developers to be able to merge directly with the main branch, deploy whenever they feel like it, so on and so forth. And I can understand this. I can understand that as developers, we want as little friction as possible, especially when, for example, pull requests accumulate and they take a really long time to get reviewed and processed. And I think these are indicative of a bigger organizational problem and not necessarily a problem with pull requests or this way of working specifically. And I'm always against using tools to solve organizational and cultural problems. In my opinion, these fundamental problems should be addressed first. Now, the topic of trust, it should be a contract or an agreement between all of the different parties involved. And that means the main stakeholders, business owners, whoever is leading the company. It should be an agreement as well with different teams that are involved, whoever is liable for whatever you're creating, as well as the engineering teams. And you should have an equal say in the amount of trust and risk tolerance that your organization is capable of handling and wanting even to deal with. Everything has a cost, and everything has outcomes, and not all outcomes are similar in all organizations. So for example, in the automotive industry, outcomes could have catastrophic consequences to the lives of people. Not everybody is building SaaS software where the worst possible scenario is an outage and people losing some hours of work, even though that is very catastrophic as an outcome. It's still not as equal as someone losing their life due to a mistake or a problem or a bug that was introduced needlessly or carelessly into the code base. And I'm not advocating that pull requests will help you resolve all of these things, obviously, but I'm just saying that whichever way of working you decide on should be an agreement between the different stakeholders. And it's not just about developer satisfaction all the time. There are many different factors that come into play, and all of them should be addressed, not necessarily with equal weight, with the appropriate weight given the circumstances and given the environment you are operating within. So what are we actually looking at here? First of all, the repository is right here. It's a very simple Go project. You see the go.mod file. You can see the CMD folder where basically all of the code is located. And we see the main.go file, which is our entry point to this whole project. And we also have a bunch of workflows that run some CI and release workflows. I'm going to create a code space because it's just extremely convenient to do so. And I'm going to edit this code in my code space and create a pull request from there. I already created the code space because just to save the time. And you can see here it's already in my browser. You can obviously connect also from your local VS Code into your code space so that you can just get started with coding right away. You can see here already my terminal is enabled, the project is checked out, and I can just get started with writing code. The first thing obviously is to run the tests. That's just to make sure that everything is running as it's supposed to. And as you can see here, the tests all passed. This means that this code is ready to be changed in whichever way we want. I'm going to collapse my terminal just because I don't need it right now. You can see here my main.go file will just execute a command. And right now we only have one command that has been registered to this CLI tool, which is my root.go file. Over here, you can see this is the code, and all of the logic resides in this particular file. And I have one more file for my tests. Okay, so the change we're going to introduce is simply adding a function where we're going to just render the output into JSON. Right now, the output is rendered as a table. So we're just going to create another function just like this one to render the output as JSON. And I already have GitHub Copilot enabled. So this is going to be a pretty easy job because Copilot is awesome. I didn't even have to do anything. Already Copilot is figuring out what I would like to do. So it has already proposed the function signature as well as the code of what I would like to achieve. I'm just going to review this and make sure that there are no glaring issues. Literally 3 tabs and nothing more. I didn't even have to write a single word or letter over here. Honestly, it looks fine to me. Maybe what I would like to do here instead of Marshall is to do a Marshall indent and then add 4 spaces for the indentation, right? Yeah, it takes a prefix, which we don't need, and then 4 spaces, right? in order for us to be able to also render, we will probably want to modify this render function, and it's just going to inspect the JSON output parameter that is passed. And if it is passed, we're just going to call the render JSON function as opposed to render table. And I think this should do it. So let us go right now to my terminal. Let us try to build this project. Not all Go projects have a make file. I already have my make file over here. That's why I'm able to call make build. Otherwise, you can call go build -o stars and gh stars, and it will build your project. Now, what I would like to also do is to run tests. And yeah, it looks like my tests have passed. Just because also I did not really write a test for render JSON. So let's actually go and do that right now. So I'm going to add it as another sample test over here. And let's see if Copilot is going to figure it out. No, doesn't look like it. Render priority queue JSON. And then I'm not going to go through really what's going on here. Just for the sake of speed, I am going to paste the output over here, just because this is not the purpose of the video to go in detail about this. And I think the rest should be just fine. Now that we've added the test, let us go and actually run it and see if it passes, and it does. Let's also run test rich in my case, which will allow me to see each and every test. And as you can see here, the test that I added is passing. Fantastic. This is exactly what I want. However, we're not done. Before we commit and we push our changes and before we create the pull request, I want to show you a couple of really awesome stuff. So one of the ways you could use GitHub Copilot chat is to actually do some security reviews and analysis of your code before you commit it and before you create your pull request. So for example, we're going to select this function that we just wrote, right? And we are going to go to Copilot chat, and I'm going to say here, given this function, I want you to tell me if there are any potential security problems that I need to address. Obviously, the prompt could be enhanced and could be improved, but GitHub Copilot can give you some advice on what are potential areas that you could improve. For example, here it says, from a security perspective, this function seems to be relatively safe. Okay, that's fine. It doesn't appear to be vulnerable to common security issues. Fine. However, there are a few things you might want to consider. Error handling. Yeah, which is good. Logging sensitive information. Also not very bad advice. And this is a great suggestion. The function pops items from a heap. The heap is shared between different parts of your program or different threads. You might need to synchronize access to it to prevent race conditions. This is a great point that is not really considered over here. We didn't really talk about the heap implementation, but it might be something that it might be worthwhile to have a look at. So this is, again, a great way to prompt Copilot chat to give you some insights and information about certain things in your code that you might and might not have written yourself. One awesome use case of GitHub Copilot as well is its awesome documentation capabilities. We no longer have to fight about whether we should write documentation or the code is self-documenting or not. Now it's just a couple of presses. We even have a macro that you can call, and it's just gonna, draft all the documentation that is necessary for you. Once you determine that this documentation is appropriate, you can just commit it and you're good to go. You can pretty much do this for all of your different functions, especially if you are exposing those to be utilized and called by other, areas of your code. This documentation and documentation hints are very, very helpful for whoever's utilizing and referencing these functions. So now that we have everything we need, the documentation, the security review and whatnot, we are ready to go and commit our changes. So we're going to stage all of these files. And then what's nice is we're going to ask Copilot to write the commit message for us, right? You see me here, I clicked on the Copilot generate commit message for me, and it says add JSON rendering option to render function. Great. I don't have to write the commit messages anymore, and they are way more indicative than anything else. So let's commit this and let's actually push it. It's obviously going to complain because I don't want to push changes directly to my main branch. What I actually would like to do is to create a pull request. Before we are able to create a commit, you can see here I already committed to the main branch, but that's not necessarily what I want. I'm going to create another branch, which is called add render JSON. I'm going to push it first of all. We need to set the upstream. Let's do that. We're going to use the GitHub CLI to create a pull request with GHPR create. I'm going to leave the title as is. And now I'm going to use the pull request template that is already provided in this repository. If you're not familiar with pull request templates, I highly advise you to start using them. This is going to take away 90% of the work that your team members have to do whenever they need to fill in information and context for their pull requests. Templates are great because they already provide the fields that people need to fill in, and you don't have to worry anymore about people not conforming to a certain, standard, or at least providing all the information necessary. I'm going to submit this as a draft, or at least I'm going to say I'm going to continue in the browser. And as you can see here, the pull request is currently in draft mode. It's not submitted yet. Why? Because the template has been populated over here, and it has already asks me a few questions that I need to fill in before I can actually submit my pull request. And let us actually go through those. So first of all, it is asking the first section, what are you changing and why? And this is where a lot of people start complaining, oh, this is redundant work, so on and so forth. However, right now you have a really awesome Copilot feature that has been introduced, which is Copilot pull request summaries. And you can click on this one, click on summary over here, and Copilot is just going to go read your diff, and it's going to generate a lengthy and very context-rich summary of all of the changes that you have introduced. All you need to do right now is just to vet and make sure that this, whatever it generated, makes sense, and that's it. Your work is done. You explained what's happening here, and if you feel that something is missing from the context, feel free to add it yourself. So this pull request adds a new function called render JSON, and it explains where it has been added. It also says that it modifies the render function to call render JSON if this flag is set to true. Fantastic. I couldn't have done a better job myself. Additionally, a new test case has been added to verify the correctness of this function. Brilliant. This is exactly the change that we have introduced, right? I mean, if we scroll down a little bit, you can see that we added this function, we added documentation, we added the test, and that's it. GitHub Copilot did a fantastic job at this. Now, it also adds a few links to the changes. These are optional. Feel free to add them or not. Sometimes they can make the description a bit way too verbose for the purpose, but it depends on your taste. Now, the next question is which environment does this change need to target? You can obviously have as many environments as you want. In this case, I'm just going to say it's dev test, and because we're not really pushing anything to production with this small utility. Risk assessment, obviously here, if you think that the change you're making is a high risk change or no risk, you need to work with your team also on documenting what these risks are and what they actually mean. In this case, this is a low risk change. A medium risk change could be, for example, it could impact some users. If you're releasing this immediately, obviously the risk category is higher, and high risk is when you are trying to do something that is not observable. You don't have any alerts for it. You don't have any logs emitted. You don't have any metrics. You cannot really figure out whether something has went wrong, and it could impact a high number of users. These are some of the criteria we use at GitHub. Feel free to adopt these and or come up with some of your own. And as I said in my presentation, the mitigation and rollback strategies are also very, very helpful to document. So for example, in this case, let's say this is feature flagged, not necessarily. If we have a problem, we need to roll back this change, and we can easily roll it back by going back to a previous commit and or just making another commit that removes these functions that have been added. From an observability standpoint, we don't have anything to add, so we can just remove this part. And as you can see here, with just a few clicks, a few presses, I have provided an extremely context-rich description of the changes that I've made, and now I'm ready to click on the Create Pull Request button. And as an author, In my opinion, this is fantastic. As a reviewer of this pull request, my colleagues, I'm sure they will be more than happy by going over this, and they will have all of the context necessary for them to come in and start reviewing the changes, right? Sometimes also as an author, I could come in and add more input over here. So for example, I can come in here, and if I'm not really happy with this, and or I want to make some, I don't know, give some more context, I can come in here and say, maybe there's a better way to write this. And then I can leave it as a comment for my reviewer. Then they can, you know, this is highlighted for them. They can come in and give me a little bit more guidance in certain areas that I feel I'm not very confident with. That's it. As an author, I submitted my pull request. Now we're going to switch over to another account where I am going to show you how you can also leverage GitHub Copilot to do code reviews. All right, now as a reviewer, you can see here I switched to my other account. I have already been assigned and or made to review this pull request. Let me assign myself as a reviewer. I can come in here and read what's really going on, understand what are the changes that are made. And now I want to scrutinize this a little bit more. So we're going to go to file changes. And one of the things I like to do as well is to do code reviews from within a code space for a couple of reasons. For one, I can immediately test things in a running environment. So I don't really have to, you know, think about how stuff should work, and I can just reason about them in a more practical way. And the second thing is I can also write all of my comments, feedback from within the code space, and I can use GitHub Copilot chat, and I can prompt it to do some of the work on my behalf. So I am running right now this pull request. It's going to be checked out in my code space, as opposed to the previous run where the code space was running in the browser. This code space is running on my local machine using VS Code. Hence the font and, you know, the theme change. And you can also see some extra extensions that are here. Obviously, you can always synchronize your local code space with any code space you create, but I'm using two distinct GitHub accounts right now. And that is why you're seeing, you know, different setups. Okay, so once this post create command has finished, it might take, it doesn't take too long. I am going to jump to the GitHub extension, because the GitHub extension allows me to see the pull requests that are already assigned to me. And what I can do here is I can just click on this, and it's going to create, show me the diff at least of the files that have been changed. So now I can just click on any of these files, and I can come in here and, add my comments. Let me remove this to get it out of the way. I can add my comments and I can review this code. So one of the things that I could actually do is to jump to the code changes. I can see them here on the mini map. One of the things I immediately spot over here is that these comments are a bit too verbose. So I can just, you know, drop a comment over here and say, these comments are a bit too verbose. Consider summarizing. I don't know, summarizing Z or an S, depends, American, whatever. Okay, I'm gonna add a comment over here. And then, for example, when I'm reviewing this, I spot something over here. And let's say I notice that we are passing a reference to the pop function of the heap. And I would like to, let's say, talk a little bit more about this, or at least understand a little bit more what's going on here. So what I can do is I can jump to Copilot chat over here, and I can say the following. What happens if we pass a bad reference to the heap.pop function, right? And it's gonna look at the code that I've already highlighted over here. And what it's gonna do is it's gonna give me some suggestions. So let's see what it says. If you pass a bad reference, like a nil pointer or incorrect type, it will cause a runtime panic in Go. This is because heap.pop function expects a pointer to a heap.interface, and it will attempt to type assert and all of that funky stuff. Great. This is actually very good. Why? Because now I can come in here and say to whoever authored this, that this could cause a panic, and it requires better error handling. Right? This is a great comment to provide. and it's a great way for us to come up with suggestions. So as you can see here, GitHub Copilot has actually helped with certain insights. Obviously, if you are an experienced programmer, this is something you should already be familiar with yourself. And having the insight to ask a question like this, right, comes from experience. So if you cannot even think of asking a question like this, you're obviously not going to be able to leverage Copilot chat. It's not going to, do the magic and work for you. However, what it can do is it can also validate some of your assumptions. So if you think that something might go wrong and you're not 100% confident, instead of going and looking around and digging a little bit deeper and whatnot, you can rely a little bit on GitHub Copilot chat to sort of nudge you in the right direction and give you some input and insight. I would love to read in the comments how you are using GitHub Copilot and what are some of the other use cases you were able to come up with in code reviews or otherwise. All right, this is it for this video. For the future videos that I'm going to be making, I'm planning a lot of awesome deep dives into a lot of different technologies. I am planning a few videos around Kubernetes, but not only Kubernetes for developers, right? Everything you should know as a software engineer when it comes to Kubernetes and how you can use it. It might extend and become a course all by itself. And I'm planning also a few videos on how you can write your own Kubernetes operators. This is definitely an advanced topic and it's not for everyone, but I've been wanting to do something like that for quite a while now, and I think it's time. I am planning another video to talk about Actions Runner Controller advanced configurations and advanced scenarios and use cases, because there is still a lot of confusion when it comes to stuff like Docker and Docker, Kubernetes and whatnot. I'm also planning a few videos on this, talking about containers, on doing another more recent video about comparing Podman versus Docker. The previous videos have been good, but I think now there has been a lot of interesting changes for Podman, and they are really competing on a lot of different fronts with Docker as container runtimes, but also from a development experience standpoint. So a lot of awesomeness is coming up. Stay tuned, and I will see you next time.